All right, here we go. Okay, so if you take a look at the note sheet that I just gave you for 2-2, you have learned these properties time and time again. All right, so there's probably nothing new here for you. So let's just take a quick scan. So addition property, you do it every time you solve an equation. You're doing these properties. You just don't take the time to break it down and think about what you're doing. But all it says is that if you start with something that's equal, if you add the same thing to both sides, so that's all I'm doing. I'm just adding C to both sides. You still have a true equal statement. Okay, I haven't changed anything. If I already have something that's balanced and I add the same thing to both sides, still balanced. I can do the same thing with subtraction. So as long as I am subtracting the same thing from both sides, I haven't changed anything. Obviously, the same thing with multiplication and division, as long as you're not dividing by 0. Okay, so that's old news, right? You've been doing this for ages. What might be new to you is this next one down, the reflexive property. And I know it looks sort of silly. Of course, A is equal to A. Why would I ever need that? Why is this even a thing? We're actually going to use it a ton. A ton. When we will eventually get to a point where we are trying to prove two triangles are congruent, for example. And if two triangles share a side between them, then I kind of get there's one side that is the same length for each triangle. So you kind of get those for free. But I have to show that it's the same by using the reflexive property. So that one will make a lot more sense in a few weeks when we start doing that. So I know it seems silly right now to just say, yeah, A equals A, big deal. But you'll see why we use that quite a bit in the weeks coming up. All right, symmetric is the one that lets us flip the whole equation over. So if you have A is equal to B, you could then flip the whole thing over and say B is equal to A if you wanted to. That's symmetric. Transitive, we use a lot. So transitive, take a look at what's happening here. You have A is equal to B, and now B is equal to C. So can't I just skip over B altogether and just say A is equal to C? Yeah, that's what transitive is letting me do. So I like to think of transitive like a train, like there's all these train cars that are linked together. And essentially, isn't the front of the train connected to the back of the train? Right, there are all these links in between, but if the front of the car is going, the back of the car is going too. So I have this link and I can cut out all the middle pieces if I wanted to. So that's your transitive property. So even if I had more of these links, so if A was equal to B, then B is equal to C, and C is equal to D, and D is equal to E. It doesn't matter. It doesn't matter how many pieces. You can always join the ends and just say that they're equal. Okay, does that make sense? All right, and then substitution. You're familiar with this because you solve systems by using substitution sometimes. That's just taking anything. If I know two things are equal, I can swap them for each other wherever I want. Okay, make sense, sort of, yeah. And then we have lots of other ones. Again, most of these you've been doing for ages and ages and ages. You do the distributive property. You know about reciprocals, the identity properties, commutative, associative. So yeah, there's lots of them that you know and you just don't even realize that you're doing. So what we are doing in this chapter is kind of getting you set up for what we refer to as proofs. And I want to sort of explain what they are. And so that's really it for 2-2. So I'm going to go right into 2-3, which will help you see how these are set up, what the deal even is with them, what's going on here. So I am going to grab my notebook. And I'm going to title this 2-3. Make sure I have the pens that I want. There it is. So 2-3 is titled Proofs and Theorems. Okay, so in order to complete a proof, we go through a process called deductive reasoning. So deductive reasoning. Is that noise coming out of the speaker? Do you hear that? Right? It sounds like there's like static in there or something. I don't know. Anyway, deductive reasoning is logical reasoning from one or more statements to reach a conclusion. This is different than what we call inductive reasoning. Inductive reasoning is when you see patterns and you're kind of going to make an educated guess based on a pattern that you see. So did I give you the whole example about Susie smoking in the bathroom? No? Okay, so let's imagine some student was caught smoking in the bathroom, right? Let's say I have caught Susie smoking in the bathroom every day this week. Is it fair of me to just assume that it was Susie this time with no other proof? Maybe it's Susie, but I don't know that, right? I don't know. I'm basing it off of a pattern. Sure, she smoked every day before, but maybe today she didn't. So it wouldn't be right of me to accuse her without knowing that that happened. So that would be inductive reasoning. There's a good chance, maybe it's her. Yes, she has a pattern of doing this, but that doesn't necessarily mean that she's going to do it again. Okay, now if I had proof, let's say I pulled up the tape and I saw, oh, she went out on the bathroom pass at 10 a.m. The smoker was caught at 10:01. I see evidence of her going into the bathroom, no one else going into the bathroom. Now I have some proof. Now I have some things where I can make a logical conclusion that, okay, yeah, it's probably Susie in the bathroom because there was no one else there and I have the evidence that backs it up. Okay, so big difference between the two. Inductive reasoning can help us, in some respects. If I go outside and everything is all wet, I know from past experience that it probably rained while I was inside and I just didn't realize it. You ever go to the movies? And I know we haven't been in the movies in a long time, but I'm sure you can remember a time you went in and it was sunny and you came out and it was like, oh, right, you come outside and you're like, everything's, oh, it must have rained while we were at the movies. You don't know for a fact that it did, right? You weren't out there seeing it rain and you just came out and everything's all wet. But based on your past experiences, yeah, that's probably what happened. That's the most logical reason or the most logical explanation. Could it have happened that the fire department was having a training that day and they sprayed everything down? I suppose, but it's unlikely. But I wouldn't know for a fact that it rained unless I had some more information to back it up. So yes, we like to use deductive reasoning whenever possible. If there are statements made, I want to use facts. I want to use definitions. I want to use things that I know to be true to make a logical conclusion. So that's my goal. I'm not saying, this looks like a 90-degree angle. It's probably a 90-degree angle. I'm just going to assume that it is because it always has been. So I'm just going to assume. You can't do that. All right. So we're focusing on deductive reasoning. Okay. Theorems. Did we define theorems before? I feel like we did. Did we? It's just a statement that you can prove. So I'll add it now just in case we don't already have it. So Pythagorean theorem, that's something that we can literally prove to you is true. A statement that can be proven. Okay, so we're going to look at the midpoint theorem right now. This one states if M is the midpoint of AB, segment AB, then AM is going to equal 1/2 of AB plus 1/2. Oh, wait, do I have this written out right? Oh, I meant that as separate things. AM is equal to 1/2 of AB. And not plus. And MB is equal to 1/2 of AB. There we go. So you don't need one when you're talking about the length of something. So you can put it, but if you want to refer to not just the segment, but the length of the segment, you can just use the letters. Good question. So let's think about this. I mean, it makes sense, if I take a look at a segment and I have segment AB, and I know for a fact that M is the midpoint. Right? So if I know that's the midpoint, I can mark these two lengths as congruent to each other. By the way, did we ever talk about congruence marks? These little slashes we did? Okay, good. Phew. So I know for a fact that M is the midpoint. I've marked it as such. So what this is telling me is that the length of AM, wouldn't it have to be half the length of the whole thing? If M really is the midpoint, right? So let's say the whole thing is 10. Doesn't that have to be 5? And then the same thing over here. MB, same thing. It's got to be half the length of the whole thing. That's all the midpoint statement tells me, or midpoint theorem. So nice and easy, makes sense. We're happy with that one. Next one is the angle bisector. Okay, and we're basically saying the same thing, just in angles. So if ray BX is the bisector of angle ABC, then, then is an N, not an M, silly goose. The measure of angle ABX would be equal to half the whole thing. As well as angle XBC. So again, if I just draw this out, you will see that I feel like this happens a ton in geometry. There's so much more that just makes more sense in picture than in words. So if you just start with any old angle ABC, and then you do bisect that angle with a ray BX. Oops. You have now created these two new angles. So again, if I know that that's an angle bisector, then I know that these two angles are equal to each other. Okay, so couldn't I say that just angle ABX, or angle 1 right here, just to talk about it more easily, wouldn't angle 1 have to be half the measure of the whole entire big angle ABC? Yeah, if I know I have an angle bisector, this has got to be half the whole angle. Same thing with this one over here. That's all it's saying. Okay, so, but you have to know that you have an angle bisector. And once I do, cool, then that new smaller angle is half the whole big thing. Okay, any questions right now? So what I want to do is I want to try a couple proofs together. We're going to start off with some algebra ones just to figure out what in the world they even are, how you operate. So I'm going to be on page 40, looking at number 11. So if you have your book and you want to follow along. All right, I'm going to flip the page and I'm going to talk to you about the two-column proof, your new best friend. Bless you. Okay, so a two-column proof. What in the world are those? What are you talking about? I'll tell you. That is so annoying. You hear that? Oh my gosh. I feel like this happened once last year and we could never figure it out. And then it just sort of stopped. Anyway, I hope it's all right. Maybe it hears that I'm talking about it. So it's like, oh, we better shush. All right, anyway, a two-column proof. So this is, we literally have two columns. On the left, we title it statements. And on the right, we have reasons. So what's going to happen is you're going to be given some information. You'll either be given a diagram, you'll be given a statement, you'll be given something, and then they'll ask you to prove something about it. So if we take a look at number 11. Okay, so let's just go through this piece by piece here. Page 40, yep. And if you look at number 11, let's see what's going on here. So they have, you'll always be given some information. So see how it says given angle 1 is equal to angle 3 and angle 2 is equal to angle 4. That's information that you can accept as true. All right, so if this given information is true, they want me to prove that this is going on. The angle ABC is equal to angle DEF. So that's my ultimate goal. They did give me a diagram. You won't always get a diagram. They did also mark the given stuff in the diagram, right? See how they marked angle 1 and angle 3 equal to each other, and they also marked angle 2 and angle 4 equal to each other. They don't always mark the diagram for you. So I want you to understand that. Whatever is given is written in words. It's not what's given in the diagram necessarily. Sometimes they mark it for you and sometimes they don't. I just don't want you to think, well, it wasn't marked. It doesn't matter. If they say in words, that's the given information. So in the beginning, we're going to give you some of the statements and see if we can fill in the reasons. So what goes where? Like, how do I even know? So statements, you're always going to start with whatever the given information was. That's always your first line. So if you're taking a proof quiz, you know what the first line is. Whatever was given to you, you literally just write it in the first spot. So if you take a look at what they have, try not to look at the answers. But see how it's set up? I just want you to see how they have everything numbered, and it's numbered over here too. So what you're going to do is you're going to start off with the given information. And then in the right-hand column where it says reasons, you need to say why you know that's true. How do you know that for a fact? So, for example, if I said something like, if the given information was that angle A was 90 degrees. Well, if an angle is 90 degrees, doesn't that mean that it's a right angle? Yeah, so then I could say in my next line, angle A is a right angle. How do I know that? Because the definition of a right angle says that its measure is 90 degrees. So there would be me using a definition as one of my reasons to back up what I'm claiming. Now, for your first line, it's always just the given information. So the first line is nice and easy because I just take literally see whatever they gave me. Angle 1 is equal to angle 3, angle 2 is equal to angle 4. That's just my first line. Okay, so I'm going to rewrite this one in my notebook. And then I know that they just have you filling in the reasons, but we're going to walk through this together. Okay, so on the left, I'm going to give whatever the given information was. Measure of angle 1 equal to measure of angle 3, and measure of angle 2 equal to the measure of angle 4. Make sure that you are numbering on the reason side too, because they need to match up. And I know that's true because that's the given information. So proof quiz, line 1, you already have some points if you just do that. Now, you can see in your book what they've done on step 2. So I'm going to recopy what they have on step 2. Eventually, you're going to get to the point where you're filling in all the statements on your own. So let's see what they've done. I'm just going to copy down what's in the book. They're saying the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 3 plus the measure of angle 4. How do they know that? How do they know that that's a true statement? I'll give you a hint. Oh, you have an answer?
Measure 1 is equal to measure 3, and measure 2 is equal to measure 4. Measure 1 plus 2 is equal to measure 4.
Yes. This 2-2, all of these properties, any one of these properties could be used to as one of your reasons. Look at what they've done. Let me break this down. See this very top line where it says angle 1 is equal to angle 3? You see that? Don't I still have that here? I still have angle 1 being equal to angle 3. But what did they do? They now added something to both sides. Not just something, but something that I already know is equal to each other. So essentially, they've added the same thing to both sides, haven't they? Angle 2 and angle 4 are the same thing. I know it. That was part of the given information. So if you add the same thing to both sides of an equation, isn't that the addition property of equality? Do you see that? Okay, you're eventually going to get really good at these, I promise. So we would just say addition. You don't want to write out property of equality every time because that's so much. Just write POE. We okay so far? All right. So now let's see, what do they have for line 3? Oh, that's interesting. They went ahead and said in line 3 that the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle ABC. Huh. Look at the diagram. Let me look. Let's take a closer peek at this. What they are saying is that this angle plus this angle is equal to the whole angle. That's a thing that you learned the other day. Does anybody remember it? That thing plus that thing would equal the whole angle. It had a name. Oh shoot, okay. I thought I was showing the answer. I'm not. Anybody have what was that? That said, if I take a big angle and I break it up into parts and I add those pieces together, it always, oh, Leanna, what is it? Yes, angle addition. Okay, you'll get used to the names as we do more and more of them. So angle addition tells you if you take part of an angle plus another part of an angle, it's got to equal the whole big angle. Angle addition, absolutely. Now, if you also notice on line 3, they didn't stop there though. They said the same thing about angles 3 and 4, adding up to this big angle. Since both of those things have the exact same reason, you can write them together on one line. I wouldn't have to do a line for angle ABC and another line for FED. You can put them together. So that's what they've done. Okay, so the reason is the angle addition. And if you don't put the word postulate, I don't care. Because sometimes there's so many ones that I can't remember. Is it a postulate or a theorem? Doesn't matter. Okay, so just tell me it's angle addition. If you want to put postulate, that's of course fine. and we also get angle 3 and angle 4 for that same reason. Angle 3 plus angle 4 together gets me angle DEF. Oh, I wrote additional. Oh, silly goose. Angle addition. Now, remember where we're trying to go. If you look at what we're trying to prove, I'm trying to get to this line right here. I'm trying to show that, oh, for Pete's sake, there we go. Angle ABC is equal to angle DEF. Once I get there, I'm basically done because now I've proven whatever they asked me to prove. So I just got to get there. The book says I'm ready. The book says in the next line, I can say this. But how do you know that that's true? What are they doing to say angle ABC is in fact equal to angle DEF? They have measures here. Oh, they do. Can anybody see? Let me zoom down a little bit. What have I done? How can I logically conclude that this is true? Does anybody see it? Oh, Eve.
Well, angle 1 and 3 are the same, angle 2 and 4 are the same, so they have to add up to be the same.
You're not wrong, but there's a way to summarize everything that you're saying in one thing. Oh gosh, Sam.
Is it the transitive property?
So if you put transitive, I wouldn't make it wrong, but it probably more, well, yeah, here's the thing. Transitive and substitution are kind of really hand in hand. Because if you think transitive is almost like multiple substitution. A is equal to B, and now B is equal to C. So I'm like doing substitution repeatedly. And then I end up just saying the first and the last are the same. So substitution and transitive, they're not exactly interchangeable, but I usually, if you give me one or the other, because they both do kind of fit, right? Because you could just think of transitive, but yeah, I'm doing substitution. I'm just doing it again and again and again. What they wanted you to go for here was just substitution. Where? Right here. They're basically combining lines 2 and 3. Check this out. See how I have, let me use a different color. See how I have this and this? They are the exact same thing, right? So what I can do is instead of writing this, I can write ABC. You see that? And that gets me ABC over here. And then I do the same thing. Where's my red marker? Here's 3 and 4 together, 3 and 4 together. So they're swapping out that 3 and 4 for DEF. So yes, I would definitely take transitive there. The book is going for substitution if you had either one of those two, because they really are kind of linked. I'll even put or transitive. And we have arrived at where, now we're done. We have proven what we were supposed to prove. Let's try an algebra one. Sometimes that's a little bit easier to sort of wrap your mind around. So do they have a good algebra one? I want to make sure that I don't have you doing one that I assign you to do later anyway. No, I never asked you to do this one. Let's do, I'm going to do number 4 on page 41. So that one is 15y plus 7 equals 12 minus 20y. So that is essentially our given information. And whenever we have an equation, They don't usually explicitly come out and say, prove what y is. That's just, we understand that that's what we're supposed to do. I'm supposed to solve this equation for y. Okay, so this is my given information. So I'm just going to write this out this time. So that's given, and I want to prove value of y. Okay, so again, they're not going to come out and say that if it's an algebraic proof, but you guys know that that's what you do with them. So I'm going to set up my 2 columns. We also get real lazy and we don't always write statements and reasons. So we just put an S and an R. And line 1 is literally just going to be my given equation. 15y plus 7 equals 12 minus 20y. Given. These are nice because you have tons of experience solving equations. You know what to do next. What might you do? Sure. Okay, you could add 20y to both sides. If you added 20y to both sides, then my second line would look like, what would I get? 35y plus 7 equals 12. What tells me I'm allowed to do that? What says that I can add 20y to both sides and I still have a true statement? Look at your list here. Who in here says you can add the same? Yes, Julia. What was the first word? Yeah, it's the addition property. If you're adding the same thing to both sides, what you did, you added 20y to both sides. So addition, property of equality. All right. By the way, that might not have been everybody's first step, right? If you personally were like, oh, I would have subtracted 7 from both sides. It doesn't matter. You would have just set it up that way. Proofs, there's very rarely just one set way that you have to do it. You usually have some flexibility in the order that you complete it in. All right, so don't feel like you're wrong if you wouldn't have done that thing first. But if that's the first thing you do, then that would be your reason. What might be a reasonable second step or third step, I guess? Yes. Yeah, subtracting 7 from both sides, right? That's what I would do too. So that would get me a 35y equaling 5. And we know that that's true because of the subtraction property of equality. I subtracted the same thing from both sides. Okay, next. Go ahead. Yeah, wouldn't you divide both sides by 35? And that would get me y equals 5 over 35 is what, 1/7? So I just did the division property of equality. How do we feel? Does that kind of make sense? We are going to practice tons with proofs. Listen, I don't expect you to be perfect at it at first. You think, well, she's probably a bad example. I was gonna say, you think Simone Biles did like a perfect forward handspring the first time she tried? She probably did. But if you just, you're new at this, I don't expect you to get this right away. So it's gonna take some time. Hopefully you eventually love proofs, fingers crossed. I love them because each one's kind of like a mini puzzle, especially when we get deeper into them and we're doing the triangle ones. Oh, just wait, you'll love them, I hope. So you do have some homework this evening. But the good news is it's not due until Friday, because tomorrow is just the diagnostic quiz. So you have until Friday to complete the following. So I'm gonna stick it right on here. And I will put it up on Jupyter in just a minute. Okay, we're gonna do page 42, numbers 9 through 11. And then on page 46, numbers 13 to 18 and 22. That's it. Don't forget to check your answers to the odds in the back. Does everybody have this? Okay, I'm going to upload the notes. Ah. You too. Bye, everybody. Have a good day. Bye. Oh, I never stopped the recording. Oh, well. Bye.
Yeah, I know.